This is AP Calculus BC Worksheet 1-3. These are going to be the solutions. I apologize that I have to whisper. I'm recording really early in the morning at about 1 o'clock. I don't want to wake up Riley. So just as a reminder, these are the orders in which we're going to try things. First subtraction, then trig identity, and then substitution. Alright, so first side of the sheet, the front side, we're doing just getting it into Cartesian using those 3 steps. So I see that I have the same t value, so I'm just going to subtract one from the other. And it doesn't matter if I do x minus y or y minus x. I actually do prefer y minus x, and the reason for that is because eventually I can just add x at the very end so I can get it into y equals form. Again, the whole point of this is to figure out what type of shape we have also. So y minus x. When I do that, I'm going to color code this too. I think that'll be really nice to see. So my y is going to be blue, and my x is going to be yellow. So my y is going to be t to the power of 2 plus 4, and then I'm going to subtract, this is all going to be in parentheses because I need to distribute that negative sign, t squared plus 3, and then from there, I want to make that black and that black. I know, I should have done it from the beginning. Okay, from here, I'm distributing, and I get y minus x is equal to t squared plus 4 minus t squared minus 3, distributing that negative. And finally we have, well, not finally, but next step, y minus x is equal to, the t squareds are going to cancel each other out here. So t squared is gone, t squared is gone, and it's going to be 4 minus 3, which is 1. Finally, we just need to add x to both sides. So adding x, we get y is equal to x plus 1, and you can see that it is a line. So this is a line. We need to box it. You do need to write the shape because that's the second part of the instructions. State the shape of the graph. The graph is a line. And really quickly, making all of my colors look really nice. Moving on to number 2. Alright, obviously I'm not going to be able to do subtraction, but I see one is sine, one is cosine, so I'm going to be using a trig identity using the Pythagorean theorem, or using the Pythagorean identity, rather. So first I need to isolate sine. So this is going to be, oh my gosh, is this the same exact one from the notes? Oh my gosh, I need to change this maybe. I'm going to divide both sides by 4, so x, it's a bad x divided by 4 is equal to sine of t, and then my other equation is y, I'm going to divide both sides by 5, and it's going to eliminate the 5 on the right hand side, is equal to cosine of t. From there, I'm going to square both sides, so it's going to be x over 4 quantity squared is equal to sine squared of t, and then over here we have y over 5 quantity squared is equal to, that's a square, there we go, is equal to cosine squared of t. Finally, we're using our identity that we have to have memorized, which is this. If I add my, I can write this slightly neater, sine squared of t plus my cosine squared of t, that should equal 1. So what is sine squared of t? Well, that's x over 4 quantity squared. X over 4 quantity squared. And I'm going to add the cosine squared. The cosine squared is this yellow function, y divided by 4 quantity squared, and that should all equal 1. And one more step to just see the correct form, which is x squared over 16 plus y squared over, wait a second, I'm like, this is a circle. I made a mistake there. That was a 5, I just did not copy it down correctly. That's a 5, this is 25, that's all equal to 1. This is a hyperbola, not a hyperbola, this is an ellipse, rather, there we go. Ellipse. I cannot spell right now, it's too late. Ellipse, I think I spelled that right. It would be a hyperbola if this was a minus sign, but it is not. Alright, this one. I have a cosine and I have a sine. So let's try getting the same type of theorem set up. So I have, oh, I already have cosine isolated, cosine squared isolated. I need to get this y one isolated though. So I'm going to divide both sides by 2. So y divided by 2 is equal to sine of t. And then I'm going to square both sides and I'm going to get y over 2 quantity squared is equal to sine squared of t. Okay, perfect. So I have a cosine squared of 2 and a sine squared of t. Remember that our theorem that we're trying to use is saying that sine squared plus sine squared of t, I should say, of t plus cosine squared of t is equal to 1. Plugging in this cosine squared is x, so this cosine squared here is just x, and this sine squared is y over 2 quantity squared, y over 2 quantity squared. I'm going to add these two together and set this equal to 1. So our next step here is, I'm going to say this is y squared over 4, and that's going to be equal to, I'm going to subtract x, so I subtracted x, and I am adding that to the 1. So that was moved over here by subtracting x on both sides. I can even write out my work, because I have enough room, minus x and minus x. Next step is to take or multiply everything by 4 and then take the square root of it. So this is going to be multiplying by 4 on both sides. 4 here and 4 here. Again, I'm going to put parentheses around this because I have to distribute this 4 into each of these terms. These 4's cancel out, and I'm left with y squared is equal to negative 4x plus 4. And then I have to take the square root of this. And just trying to make sure I'm doing this right. Yeah, I don't think I've made any mistakes yet. This is, I'm going to take the square root of both sides. Take the square root of both sides. This is equal to, y is equal to, it should be plus or minus the, I'm realizing that this is a circle, but how do I explain that it's a circle? It's not a circle, it's a semicircle, isn't it? No, it's not even a semicircle. What is this? Is this a, how would you describe a square root function? What type of shape is that going to be? It's plus or minus. I'm just going to leave this as the square root of, I can kind of switch around the order and make it look cool and fancy, 4 minus 4x. So in my mind, what is happening in the graph, which might not be correct, but I have a graph that looks like this where it's negative 4x, and the normal square root function goes like that, but because it's negative, it's going to be coming out like that. So it's some square root that looks like that. I don't know how to describe that curve aside from it's the square root curve. But let's actually graph this to make sure that I'm doing this correct. So if I go to Desmos and start graphing, I could just graph this, or I could graph this. Let's graph this to make sure I'm doing it correct. So I have cosine squared of t, and I'm going to do 2 sine of t. 2 sine of t. And I'm going to go from negative 2 pi to pi. Oh, what is going on? I can change it to 2 pi. It's not what I thought. Huh. What is going on here? What happens if I go like this? Let's graph this function. Y is equal to plus or minus. No, it doesn't let me do plus or minus. I'll just do the square root of 4 minus 4x. 4 minus 4x. Huh, that's interesting. So we have that part of the curve correct, but it is only showing us a different part of the curve. So why is that? It has to do with a domain restriction. Okay, so we have the function correct. I was thinking of just this blue function, but the reason that we have the red function is we are supposed to have a plus or minus, so technically I should have this function right here, and I can do y is equal to the negative version of that as well, square root of 4 minus 4x, which gives me the entire function. So if I turn each of those pieces off individually, you can see, yes, they are definitely the answer that I'm looking for. But I'm not allowed to have negative values for x, and the answer for that is pretty straightforward. Whenever I square anything, this should always be positive, so my domain should always be positive. I don't know what type of shape I'm supposed to be doing, but let me graph our answer. Our answer should look like this. It should go like this, and then I'm going to do a dotted line out here because this doesn't exist. And it should come down here as well, and then not exist. It's just where that solid line is. And I'm going to, maybe this is a bad problem, I need to fix it. I'm going to call this the square root curve, for lack of a better name. Number 4. So it looks like we cannot do either of the first two methods, so I need to do substitution, the very last one. So I'm going to isolate this t because it's easier to isolate than that t. When I do that, I'm going to subtract 3 on both sides, minus 3, so I'm left with x minus 3 is equal to 4t, and then from there I'm going to divide everything by 4. So divide the right-hand side by 4, divide the left-hand side by 4, and those are gone. I have my t value. My t value is equal to x minus 3 divided by 4. That means that this t value is also x minus 3 divided by 4. Let me copy that down. So this is now y is equal to 16, and in parentheses here, this t value is, as stated earlier, x minus 3 divided by 4. And that's all quantity squared minus 9. All right, so let's simplify this a little bit. This is now going to be y is equal to 16 times, so again, when we square the top, it's going to be square the first, double the product, so the product of x and negative 3 is negative 3x, times 2 is negative 6x, and then square the last, it's going to be plus 9, all of that divided by 4 squared is 16, minus 9. So notice cool things start happening here. The 16 and 16 cancel each other out, and now I'm just left with x squared minus 6x plus 9, but plus 9 and minus 9 cancel each other out, and I'm left with y is equal to x squared minus 6x. And that is the form of a parabola, a quadratic. So the answer here is a parabola. Whew, all right, that was easier than number 3. Now we need to convert from polar to parametric, and there's our review. We have 4 problems to do. They're all pretty straightforward, though. So I just say x is equal to, copy down this thing. So x is equal to 5 plus theta, that's been copied down, and then times cosine of theta. That's half of the battle. Here's the other half of the battle. Y is equal to 5 plus theta times sine of theta. Done. All right. Again, x is equal to negative 7 theta times cosine of theta, and y is equal to negative 7 theta times sine of theta. And you might be kind of rolling your eyes like, wow, this is really easy, and I'm realizing the same thing. Yes, it is very easy. X is equal to, ooh, this is going to be cool, so it's cosine theta, which is our r, times cosine of theta, which is our definition, which means this can be simplified to cosine squared of theta. And our y is equal to cosine of theta, which is what we are given from r, times sine of theta. Done. All right, and our final problem for worksheet 1-3, this is going to be x is equal to sine of 4 theta times cosine of theta. And y is equal to sine of 4 theta times sine of theta. And this one is not sine squared because you have a different argument, a different inside. And yeah, that's our last problem. That concludes worksheet 1-3.